Yes. Yeah, so thanks for having me as the last speaker today. I'm here to talk about Docker at Cloud9. So I'm Lennart. This is my Twitter ID. Let me first tell you a bit about Cloud9. So Cloud9 is a startup. We're based in Amsterdam. We have offices also in San Francisco. We're at the Lauriergracht. There's a picture of Breitner of our gracht. It's quite a charming office, although I mean this bunker is nice. So I mean, I've seen at some meetups that the ulterior motive was really like a product pitch. I mean, that's not why I'm here. But what we would like is actually to hire a guy. I mean, we do actually hire people. So that might be one of the ulterior motives for me. Also would like to tell you a bit about our new product as context of how we use Docker, what technical problems we faced, and specifically tell you about version 3.0, which is the third version. We released this in July, and it uses Docker. So, who of you has actually heard of Cloud9 before? Okay, well, it's quite a few. So for the others, they have no idea what I'm talking about now. So Cloud9 is an online IDE. It's an IDE in your browser. Here's a screenshot showing you what Cloud9 can do. So you have a split view here. We have JavaScript code at the top. You see like arrow markers. We have type inference for JavaScript. Like things like jump to definition. For PHP we have code completion. We support Go, Python, Ruby, some other languages. Outline view. So I mean, you get really a full IDE experience in your browser, which means you don't have to install anything. You just open your browser, you open a URL, you share that URL, and you have an IDE. Other things we have is a debugger. This is one of the things we started out. I mean, originally we were really focused on Node.js, so JavaScript on the server. We made a Node.js debugger, and gradually we noticed a lot of other communities, especially the PHP community actually, are jumping on this. I mean, these guys are web developers, so they can see the appeal of an online IDE. So we started expanding, started supporting more languages. Some more features. So we have like a preview. If you're a web developer, we can show a preview of your code. We have collaboration with Sauce Labs, which means that we can also show a preview of how it would look on an iPhone. It's a nice web service they provide, and we integrate that, essentially showing their service in an iframe in our interface. So, I mean, you can preview your web pages on iPhone. You can use IE6, Firefox, and do browser testing that way. It's quite awesome. Other things is you have a terminal. I mean, some people just like to use the terminal in full screen like this. You can use VI if you don't like our editor. And I mean, you have the split views. The nice thing of our terminals is that they preserve the state. So I can close my laptop, I can go home, use my home computer. My state will still be like this. I mean, I can just log into my ID and it saves everything. We're seeing people doing lots of interesting stuff with our product. One thing is a recent tweet by some guy that used it for his kids. So apparently he's making this game with his kids, and what I found really awesome about this picture is actually this little drawing here. You can see apparently they scanned that in and used that in the game. That's quite amazing. And well, the last, and this will sort of end the product picks kind of part of this talk. Last thing we have is it's like Google Docs for code, which is like our old slogan. So you get collaborative editing. You get multiple cursors if multiple people open the same workspace, and they can go together. And this is especially useful for pair programming actually, where you get to have two keyboards sit next to each other or work remotely. So this product, Cloud9, is about 300,000 lines of JavaScript source code, which is a lot. I mean, this is client-side source code. obviously, but also server-side source code because we use Node.js. And I mean, to manage that, you need a good ID, and we use Cloud9. But yeah, other than Node.js, we support other languages. So I mean, we really saw, especially this PHP community add-us coming, and we saw in our metrics, hey, there's lots of PHP users, and we barely provide anything for them. So at some point, we started with workspace types. I mean, rather than just having a Node.js project with like a Hello World program in Node.js and everything set up so you can get started, we also have something like that for other languages. So we also know that C++ was somehow taking off, so we added a workspace type for that. Now people still use C++. But that is a lot of configurations, right? I mean, all these different languages, all these different frameworks that we have to set up. So we were like, how can we manage all these configurations and do that efficiently and I mean maintain that? And well, the answer was Docker. I mean, you're sitting here, so you knew the answer. But Docker is the answer. And I mean, Docker is just really awesome for us. I mean, Docker is really fast. There's almost no overhead. It's like just running a process rather than having a VM set up with its own memory and so on. It's just a process with a couple of flags, barely any overhead. It's also really inexpensive for us. Because of this, having so little overhead, you can run a lot of Docker containers on one machine. And I mean, we have a freemium service, which generally means like you have 90+% users that don't pay for your product. But you still need to finance that. I mean, you still need to host that. And then using Docker is great. The other thing is this reproducible environment that Docker provides. With Docker files, you can just really accurately describe the configuration and deploy that to many machines, many containers. And I mean, Docker does a lot of work for you there. And this copy on write storage they use is very useful there. And I mean, for users, I mean, these Docker containers are just very flexible. I mean, in a Docker container, they can do, say, sudo apt-get install, and they can install their packages, they can install their dependencies. It's like a small VM for them. I mean, that's how we use it. So I'm going to show you a bit of how that looks. Okay, so you have to bear with me a bit because I'm on tethering. But one thing I wanted to show you is actually a really fun project that a colleague shared with me. It's called HTTP Tris. So this is a... Sorry?
Can you zoom in a bit, please?
Yeah, let's make this larger. Right, yeah, I mean this is just a browser, so we just zoom, right? Command plus. Yeah, so this project of his, it's some kind of Node.js project. It runs in this Docker container. I haven't touched it in a long time, but since it's its own container, it's not in my local machine. There's no way something can break it. I mean, there's no dependencies that going to get updated. This will just keep working when I open it again. And interestingly, there's even an old terminal open here that was doing like a file listing kind of thing. Let me try to resize that. Yeah. So this is apparently what was happening last time on this machine. So I can run this. Save this. I am getting some responsiveness problems due to this whole tethering thing, it seems. Ah, we got network. Here's the dongle thingy.
Zou moeten doen.
Okay. Okay, so let's refresh. Yeah, so we're still here. Apparently it did accept my run command. stop this and yep, start again. Yeah, I mean, like you can see we have these split views that you can use to drag things wherever you want them. Still not having much luck with all internet, it seems. Yeah. So I mean, this is one of the things we have right now, right? I mean, we don't have internet everywhere, and that is obviously a drawback of having an IDE in the cloud. But yes, I'll be honest to admit that. But I mean, imagine that I'm at my grandparents' house and someone is yelling like, "Hey, one of the servers is down, Lennart, you should come have a look at it." I mean, I can log in on my grandparents', a Windows machine. I can log into my workspace and I have everything there, and I can access all our production machines, I can access our source code, I can do deployments. I don't need anything. Well, I convinced my grandpa to use Firefox. I mean, he's 97, but he's been using computers for quite a while. He's quite savvy that way. But no, we don't support Internet Explorer. Now, the other thing we want to do is actually bring Cloud9 also to the desktop and have this whole offline syncing, which will be version 3.1. But that's still a secret. Don't tell anyone.
I have a feature request, by the way, just in short. Can you just make some random jokes or something when you have a error message that you're disconnected?
Random jokes?
Every time, like I can...
Yeah, I don't think that will help a lot. So, yeah, I mean, conferences are often like this. I mean, where you cannot really trust the internet. So I do actually have like some backup slides with some screenshots. And I think at this point I should just switch to that. So this HTTP trace is like a small Node.js server. You can run that, and it's like Tetris. And the fun thing is there's like these HTML links. It's pure HTML implementation of Tetris. So it will keep refreshing the page to redraw this, and it's great fun. And the other thing I wanted to show is actually my dev machine, which is what I use every day. And I mean, where I work, I have internet. We're a cloud company. So what you can see here is a Docker file, and I imagine this is pretty small for most of you guys. But this Docker file is what we use for WordPress files. So there's a couple of configuration things. We get the latest WordPress image, we set some settings, and we base that on the base Cloud9 image. So we have a Docker file like this for every one of our workspace types. And we have one base Docker file with all the basic configuration of our Ubuntu system, installing Node for all users, installing Rubies and so on. So this is like the base setup, and I mean our Docker images are based on this. Another fun thing to show is D9. So D9 is like C9, Cloud9, but then for Docker. It's a command line tool. I mean, I'm really fond of the command line, and it's also one of the reasons why I got into Docker. I mean, it's a command line tool to access our production systems and to test Docker things. And a lot of the things you might recognize from Docker itself. So you can do like a D9 run to run a container. Do a couple extra things, set up quotas and so on. You can do D9 SSH and SSH into container, D9 RM. There's a dry run where you can just in a matter of a fraction of a second start a container, run some command and stop it again. And we have things like Fedora and so on. But let's just get back to my original slides. Tell you a bit about our software stack. So, like I said, we use Node.js. We have something called Docker.js that we built. We have this D9 thing, which is actually a shell script, D9.sh. And we have Dockerode, which is a node bindings library for Docker. So below that is Docker. There's micro-identity, which is like a service thing for SSH servers. Dropbear is our SSH server that we use. And we use Tmux, which some of your Unix gurus might recognize as like a replacement for Screen. It's very useful for persisting terminal state. So D9 is like our main thing we use to control Docker. It's a shell script. We copy many of the commands that are also in the Docker command line tool, and add things like do a dry run, inspect all the attached containers, all the active containers on the machine that have like an IDE attached to it. Do a self-check, do a health check, and a lot of that thing. So our ops guys use D9 all the time to get a feeling of the system, just in the command line, in addition to other interfaces we provide. Yeah, so let me show you a bit of our architecture. I mean, this is like you again. You access our cloud. There's a lot of load balancers, DNS, region-based stuff. You eventually come into this IDE server. It will give you some static HTML files, so JavaScript. That will tell you to use one of our VFS servers. VFS server is like a proxy thing that connects you to one of our Docker hosts. And we have multiple Docker hosts. We have multiple VFS servers. Actually, each one of these red lines is like a one-to-many relation. I mean, we're a cloud system, so we need to have all these things at scale. And yeah, I mean, a Docker host has many Docker containers. Other than that, we have some servers for security. We work together with the security company. I mean, we have Docker containers where people can run anything, so security is a concern. We do backups about every 15 minutes of Docker containers, so more servers. And I mean, the general challenge is just managing all these different Docker containers in the cloud for so many users. I mean, we have about 350,000 users total, and we're seeing so many new registrations since new release. I mean, that is just the main challenge. I mean, keeping up with that. And so I'm not going to go into all the challenges in this talk, but I'm going to at least glance at some of them. So one of them is load balancing. So, I mean, if you have, like, for example, 10 servers, you get 1,000 users, we would like to evenly split those over these servers. Generally, we tend to have less users over 10 servers, but still. So how can we do that? I mean, users will go online, they will work a few hours, and they go offline all day, perhaps. So that's a pretty big challenge. I mean, that means that you need to have these Docker containers that are not active, you need to move them elsewhere. So can have balanced loads of all the Docker servers. Generally we do that on a lot of metrics, like how many active containers are there, how many total containers, what is the CPU load. We use that to do this load balancing kind of thing. Other things that we have is regions. I mean, we have users all over the world, so we have servers in Europe, US and Asia on the Google Cloud Platform, which is like the new Amazon. It's better. Yes, and yeah, we need to deal with that. And we also have people that actually travel between Europe and US, and we need to make sure that their containers are moved after them. Because, I mean, our ping times are just really important. It should be below 100. And anything above that will be unacceptable if you type in a terminal. So other things is like we have server upgrades. I mean, at some point we need to have a new kernel version, a new Docker version, and generally we just add a new Docker host and then make sure that all the users are moved to this new host rather than like reboot the system, install a kernel. And that would be pretty unacceptable to many users. So what we really want for all these things is to move running containers to another host with minimal impact to users. That's pretty hard. And I mean, we don't really have an answer for that. I mean, I know that there's some LXC people working on something like this, but Docker doesn't seem to actively work on that. So what we do is we sort of cheat. Basically, we back up containers when there's no user attached to it. We back up containers all the time. And we persist all the data that is actually on disk. So we keep their file system, we keep the original image name, the revision, we store that in the database, and we can restore that to any host. But that will destroy your running state, so it's not nice. I mean, we want something better for that. And for premium users especially, we try to not move them so much. free users we have other guarantees, so we can move them, and that will really help with the load balancing. But yeah, I mean, this is one of our biggest concerns with Docker right now as we use it. Yeah, so we use Docker Hub for downloading these images. We have Google Cloud Storage for downloading and uploading these backups. So there's a whole lot of red arrows here. And the other thing we ran into with Docker is bugs. I mean, we started to seriously use Docker with 0.6 in a beta after doing tests with it. And every version after that would have one problem fixed and another problem that we would find out about after maybe a week or two. And that was a problem with Docker, and it's gotten better since, but it's still something that really concerns us. So what we do is, yeah, I mean, if you create a container, we try that. If it fails, we try it again, and we do that like 10 times. That's one of the basic things we do for everything. Stopping a container, same thing. Docker won't always stop your container. It will sure do it for the first 1,000 containers, but the 1,001st one, nah, it won't stop it. And there's still some of those things like that, so we do need those retries. We do need workarounds for issues that we find. We do lots of logging and monitoring. And, I mean, we've started to become somewhat conservative with Docker updates, because we have seen that they bring regressions. And at this point, we're like at 1.0 with a fork and patches that actually fix problems rather than introduce new ones. So, I mean, that is really tricky, and we want to keep up with Docker, and we're going to do that. But for that, yeah, the biggest thing we need is, and we're doing actually, is stress testing. Every new Docker version, we do a big stress test, creating these 1,001 containers and see if it goes okay. And we do lots of monitoring of the systems. And Datadog is a very useful system for that, and you get all kinds of nice graphs. Yeah, like I said, it got better. I mean, version 1.0 added production support. It's a notable feature. Yeah, so this is my to-do slide. So what we want to do after this release is open source our Docker files, allow users to roll their own Docker files, because we just have these fixed workspace types right now. And also start using Docker ourselves more, because I mean, we've been building services for a long time, and we haven't actually used Docker in that sense for like running our own services. I mean, just for running these user containers. Okay, so to summarize my talk, I mean, Docker rules. Shell is very powerful. Some things could be better in Docker. I mean, load balancing, we've seen lots of problems. Didn't get into CPU and disk quotas, but there's lots of issues there. Also, I mean, if you like plain Docker, if one user does a 4 pump on one container, it will take down the whole host. So we have a lot of kernel patches for that kind of stuff. And, Docker should be doing the other. The other thing is bugs. I mean, that is really frustrating for a production system. Docker is adding all these nice features that we don't use yet. We may use them, but it's also adding regression. So for production, it's almost still moving too fast for us. But I mean, we need it. It came just in the right time for us. So I mean, Docker is great. It rules. And yeah, like I said, there's more coming for Cloud9 and Docker. Open sourcing, custom images, everything. And we're hiring. Okay, thanks. So, questions?
Do you have an Emacs compatible boat?
Why would you want to?
I'm not an Emacs developer, but we use Fluidbits badly because it's terrible for developers that work in Emacs and developers that work in
And so we do have a VI mode. We have an Emacs mode, but I don't think it's quite as complete as the VI one. So there is something, but I don't know how extensive it is.
Can developers collaborate on the same file with different editors at the same time? Different editor modes?
Editor modes, definitely. I mean, editors is trickier. I mean, we do watch all the changes on the file system, but you should generally use the Cloud9 editor with whatever mode you like.
So how actually do you do the load balance? Like, maybe I missed that completely.
Well, essentially, at some point we look at containers. If they're not active, we will deep freeze them. We will make sure that everything is in a backup. No processes are running is easy. If processes are running, yeah, we're like, if this is a free user, then okay, we're going to defreeze it after 10 days. If it's a premium user, then we'll just keep it running. But we have so many free users that will already account for the load balancing.
All right. But it's not, yeah. So did you look at the fleets from the earlier talk or Kubernetes?
Didn't look into it. Do they solve this?
Sorry?
Do they solve this?
I think so. Well, they distribute the load around your
Yeah, but I mean,
hosts, right? So you just keep on creating.
yeah, but if I have like a node process running in one container, can I move that container to a different server?
Well,
Not with
yeah.
the state.
Okay, but then run it in ESX or something and use KVM and migrate your memory to different machines.
Yeah.
Use-
No, migrating memories need what these LXC people have been talking about, but I'd really like that as a core Docker feature.
Yeah, so run your Docker inside VMs that you can transport.
Yeah.
And then you can just
Okay,
reload
it's interesting.
They're hiring.
Can you not diff containers? Just send diffs like continuously, and then swap to the latest.
Yeah, well, I mean, this runtime state is the hard part. I mean, the disk diff is easy, but runtime state, yeah, maybe KVM can provide something there, or something like KVM.
They do.
How do you get your file system state?
We use AUFS.
Do you have one container per client? One container per state?
Yeah, what I didn't really get to show is, I mean, as a user, you can just create multiple workspaces. So every workspace is one Docker container.
So they have sort of one data container and probably.
No, I mean, the container runs an SSH
project
process.
Each project has a couple of containers to build that up.
No, generally it's just one container. I mean, if I have my HTTP trace project, there's an SSH process running there with a terminal. I can start Node there, and that's it. It's just this one container. So no multiple containers for
So
one
it has
project.
its own data, it has its own.
Yeah, own file system.
Yeah.
But your source code is also just in the container. If you write a program that just empties your container,
Yeah.
then you also lose your source code. Or is that separate?
Well, the source code is persisted on disk, so that's not so hard. It's really the runtime state that's hard.
Can you couple to CTF or Git?
Sorry?
Can you couple to a version control system?
Yeah, absolutely.
So that already solved that.
There's actually a need for memory snapshots.
Yes,
To become persistent.
indeed.
You also have containers crossing because of bots.
Containers, what?
Not containers crossing because of those bots that you mentioned. And crossing from
This has happened. With earlier versions of Docker, we would see entire hosts crashing. I mean, we've seen kernel crashes, we've seen like the Docker daemon process dying, and all the containers.
What do they think about that?
Sorry?
What do the customers think about that?
Oh, that was still in the beta.
Container quite fast up and running, but
Yeah. No, I mean that's just no good.
the customer prefer to wait 1 day and have the, let's say, stable container rather than getting
Yeah.
a second and having crossing every week or something every month.
Yeah, it cannot crash. But we've not seen that anymore since 1.0.
And then now with the workarounds and everything, you have a stable situation.
Yeah.
And those workarounds, is that really crazy or is it?
Well, like I said, it's mostly retries. There's some crazy stuff in there, and I mean we started out using ZFS actually, which should be stable, but ZFS on Linux is somewhat less stable. And if you have like two unstable things, you have Docker and ZFS, you have like the exponential amount of problems.
But
So, can I ask, is there a more direct question which is not so much discussion-like? Because otherwise, we kind of have like 15 minutes in which a lot of people can still be here without needing to catch their trains.
Cool. So short question then. No short question.
Then it's all discussion on the floor.
Yes. Beer
Thank you
time.
very much.